Okay, so let's look at the answer to this. So first of all, the rock goes up and down. So what's the displacement? Well, it's just the final minus initial, right? The final position is here and the initial position is here. It doesn't change, so there's no displacement. This displacement is 0. However, the total distance is 10 plus 10. So it's 20 meters. Okay, so displacement 0 meters, total distance 20. Okay. For this one, the rock goes up for 5 meters. Bad handwriting. 5 meters, and then 30 meters down. Okay. So now the displacement would be, well, I need to describe this point minus this point. As soon as I describe points, I need to describe a position. So I need to put in a coordinate system. Okay, so I'll call this y, right? And I'm going to call this 0. So my starting point here is 0. And this point over here is minus 30. And this point over here, the highest point of where the rock goes is 5. Okay, so the displacement is really the final point minus the initial point. The initial is at 0, and then it's 0. So the displacement is just this part, but it's in the negative direction. So it's negative 30 meters. Okay, so I kind of stare at the diagram to deduce that. You can do it more formally, right? So you can use the formula. It's the y final minus y initial, right? S in the y direction. S in the y direction. So y final is minus 30, minus initial is 0. So you get minus 30. Okay, so either way works. You can intuit it. So just stare at this and think, okay, so the displacement, I don't care about the part where it goes up and down because that part, the displacement is 0 anyway. But the part that goes down is it's minus 30. It's 30 meters downwards. And because this is fully in one dimension, I can basically just use plus or minus to tell me the direction. But for 2D, you cannot just do minus and plus. The distance, we have to be a little bit more careful because there's a turnaround point. So you have to watch out for turnaround points when there's distance. So remember, just like the graph where I have different segments, as soon as you change the direction, you have to separate it out and look at it separately. So this part there, it traveled 5. So, right. And then this part, it just goes straight down. There's no change in direction. So go straight down here. It travels 35. Right. So we're going to look at just absolute values of everything. So the total distance is 5 plus 5 plus 30, like that. Okay. So that would be 40 meters altogether. Okay. All right. So finally, number 3, I'll give you a second to copy this and I'll get save some space, or you can pause the video. And now we'll look at it going from north point to the west point, right? So part A, it goes from here to here. Now the displacement is the direct distance, or it's this vector, right? From the initial to final, like this. That's the displacement. Okay, so you can, if it doesn't specify, do you need to put it in components or geometric way? You can do either the magnitude direction answer or the components. Okay, I'll do both just in case in the future it's asked. In my notes, it actually asks for magnitude and direction, but I'll do both just in case, right? So magnitude and direction. So if this is, so what is the magnitude of this? Well, this is a circle, right? So the radius is 10. So this is 10, this is 10 meters, everything is 10 meters. So what's that? So you can do 10 square plus 10 square root. So that's going to be 200 or 10 root 2. Right? So either way, you in physics, if you're shaky on your square roots, you can just plug that in a calculator because in physics You just need to give things in decimal places to the number of significant figures that the problem is given in. But again, like I said in previous lectures, we don't worry too much about the significant figures, even if you're 1 or 2 off, as long as you don't put like ridiculous amount of significant figures, like 17 significant figures, then you're fine. So roughly the same as what the problem is given. That's the general rule of thumb in physics. Yeah, so I don't want to waste time, put in a calculator, and I'll just give the answer, right? So the magnitude, so for the displacement, the magnitude is 10√2 meters. Okay, that's roughly 14.1, something like that, because √2 is 1.41. But yeah, you can double check. So it should be 14.1 meters, something like that. And the direction is, this is directly to here, right? So this has to be 45 degrees because it's an isosceles triangle, right? So it's in the northwest direction, right? So it's in the northwest direction. If you want to be, so technically that's good enough, because in the cardinal framework, you can you can use the northeast southwest to give directions. If you want to be a little bit more rigorous, or just in general, right, you want to write 45 degrees which way? So this way, right? So 45 degrees west, west of south, or 45 degrees south of west. Okay. In that case, I am looking at that. But yeah, you get the idea. All right. So if you want to get, so this is the displacement. Let's write the distance as well. The distance traveled from here to here. Now, I didn't travel along the red line. I travel around the circle. So I need the actual distance over there, right? So that's 1/4 of a whole circle, right? So what's the whole circle? That's the circumference is 2 pi r. So that's 2 pi 10, right? So that's 20 pi. That's the whole circle. So that's the whole circumference. I just need 1/4 of that. So 1/4 of that. So the distance is 1/4 of the circumference. And so that's 1/4 of 20 pi. So that's, by the way, for a good presentation, usually try to write your steps going down instead of going across. Let me do that properly. The benefit of that is this is more professional writing. So everything is traceable. So 1/4, 1/4, C equals to this, right? So just a tip for your exams and things. If you want to make your work look professional, go down instead of go horizontal, right? So that's 5 pi. Again, in an exam, put that as a significant figure, but that's essentially it. Do you need to give the directions for this? No, distance is a scalar, so you don't have to. All right, good. So so that's what the question asked for, magnitude, direction. But if they ask for components, then you want to resolve this in component. So that's 10 units this way and 10 units this way. So if I overlay that with the XY direction, that's the reason probably why the textbook didn't, or the notes didn't have ask for the components, because this is in northeast southwest, right? But if it does, right, so you will write this is negative, right? So it's this way and this way. So -10 this way and -10 horizontally, -10 vertically, like that. All right. And okay, so part B, the displacement is, I could use S, but I've written that already. So from here to here, right? So draw your vector first from here to here. Okay, this is relatively easy. This is just 20 meters because it goes straight across the diameter, so 10 + 10, 20 meters in magnitude. In the what direction? In the southwards direction. South. We'll just put in brackets the direction, right? So that's part of the answer, magnitude and direction. I'm not going to put it in component form. It's just 0 - 20. And distance is, but distance, this time I've gone all the way halfway through here. right? So it's 1/2 of the whole circumference. So this time it's 1/2 of C, right? C is 20 pi, so 1/2 of 20 pi, running out of space, I'll just write it across, is 10 pi meters, like that. And you get the idea for C. This time we're going all the way here. In fact, the distance looks like it's easier to calculate. I'm gonna, since I'm on a roll, I'll go with that first, right? So 5 pi for 1/4, 10 pi, this is going to be 15 pi meters, okay? And D, the distance is all the way through, so the whole circle circumference, which is 20 pi, right? So displacement is, so from here to here, this time, the displacement is from initial to final, right? Over here. So the distance is again 10√2 meters. Sorry, the magnitude of the displacement is 10√2 meters. And the direction, how do I know that? Well, it's the same as this, right? So just looking at, that's the same as part A, but different direction. So the same magnitude is the same. The direction is this time in the northeast direction. Sorry, southeast direction. Did I get that wrong? South of west, northwest. Aha. That should be southwest. Okay. If you spot that before I did, well done. Southeast. Bet you guys are like typing in the comments. All right. So and displacement for this guy. What is it? So if I go the whole circle, have you got that? That's probably the easiest part of the whole problem is 0. Displacement is 0. I've got a question before. What's the direction of that? If a vector's magnitude is 0, what's the direction? The direction is NA, not applicable. So when your vector has 0 magnitude, there's no need to put in directions, okay? You don't have to put anything at all for directions. I'm just putting that to emphasize it, okay? All right, so yeah, just to elaborate on that, right? So if a vector has magnitude, technically a magnitude and direction, but if the magnitude is 0, essentially, do you have any arrows at all? Remember, vector is an arrow, right? So most arrows have length, but if you have 0 length, that means you don't even have an arrow. If you don't have an arrow, you don't have, essentially you're saying you don't have a magnitude and you don't have a direction, okay? You have nothing, 0. All right. That's how you deal with 0. So it just doesn't exist. There's no magnitude, no direction, okay? All right, so if you like, you can put NA undefined or just nothing, just don't put it. You won't get any points deducted. And those are the solution. Let me know if you have any questions or if I made any other mistakes. And I'll see you in the next lecture.